Is on boiler mountings. We're going to see about the boiler mountings. We not only read it theoretically, we're going to see how exactly they are mounted upon the boiler actually on board a ship. So let's start with the boiler mountings. When somebody asks you what are the boiler mountings, you got to start from the top. You got to bring the picture of the boiler in front of you and then imagine and then say all the mountings right from the top to bottom. Let's start one by one. So a boiler must have two safety valves, an air vent valve, main steam stop valve is required, but auxiliary steam stop valve can be found only in medium to high pressure boilers, a pressure gauge, two independent water level indicators, and out of which at least one must be present on the boiler in local, and two independent feed check valves. One will be main feed check valve and with the water level controller, and other will be the auxiliary one which doesn't have the automatic water level controller. And it must have a sampling cock, a scum blowdown and bottom blowdown, and a peephole. So not only we are not constrained only with these mountings, we have others too. These are not called as mountings, but these can be said as accessories. So these are easing gear, feed water controller, and you can call it as water level controller, combustion controller, soot blower, gagging tool, and plugs, which are essential for a boiler to be safely operated when the ship sails out at sea. So let's see one by one how and where they are located on the boiler. First we start with the safety valve. Now we have two safety valves over here, and the boiler main steam stop valve and a pressure gauge here. These are all located on top part of the boiler. And here is the water level gauge glass. As I said, we have to have two independent water level indicators, out of which one has to be local. So this is the local one, and the other one can be a remote water level indicator or two gauge glasses. And since the water level is over here, you got to have the scum blowdown valve here, and you have the burner here and the blowdown valve, two blowdown valves here. So salinometer, sampling cock, and the feed water inlet valve cannot be shown in this section, so we will see actually how they are located now. We'll start with the safety valves. So this picture has been taken exactly on a boiler how the safety valve is. So these are the two safety valves which comes from a common chest on top of the boiler, and they have separate waste steam outlet. They should never be connected together, and it has the easing gear wire arrangement here so that during any emergency you can ease up the safety valve. That's why it's called as easing gear, just to relieve of the steam pressure temporarily. And the next picture shows one more arrangement of a safety valve. So this wire goes through a pulley mechanism and down to the boiler combustion area, so that one need not to climb up two platforms top to operate the safety valve. They can operate it from the remote and safe location. That's the reason we have a wiring mechanism with pulley arrangements. So one must be interested in knowing what is this on the waste steam pipelet and a drain pipe going over here. Let's say the safety valve outlet is going to the funnel and there is some rain coming out. There are chances that water might come in, and if this is not provided with a drain arrangement, this can accumulate on top of the valve, adding the lifting pressure of the valve. Let's say the boiler safety valve is set to lift at 7 bar. With the water on top, it might lift at 8 or 9 bar, who knows. So you got to have a drain collecting mechanism and a competent drain to drain the water continuously if there is heavy sea out there. And one more close-up snapshot of a safety valve. During frequent inspection, you got to inspect this bulldog clips. There are chances that due to age of ship and vibration, the bulldog's clip might give way, and when you want to ease up, this gives way. You can't operate the safety valve. That should not be the case. And Let's see now how easing gear works. When you pull the gear, that is a lever from the boiler platform, this is somewhere 2 platforms up from the furnace area. So when you pull it, this will be lifted up. Let's say I run to the boiler operating platform and I pull the easing gear up. So due to the pulley mechanism, this wire is pulled up and this drags the lever this way, which means there is a small cam-like surface, a projection over here, which goes and strikes on this plate and then just lifts up the valve spindle. When the valve spindle is lifted up, the steam escapes out to the waste steam pipe. So that's it. And now this is a small air vent valve. It's a very simple valve, just with a valve handle. Just we can open, and this air vent, it should not be just opened up to the atmosphere. It has to bend and go down to the boiler coaming, right to the boiler operating area, and released in the funnel on the coaming. It has to be safe way. It has to be in a safe way, in fact. And this is the main steam stop valve. I can't remove the lagging and take up the picture, but this is a simple right angle screw down non-return globe valve. It can differ in various arrangements, and it should be noted that you never have to throttle this valve. You got to always keep it either full open or full shut, as this is the only valve between the boiler and the entire steam distribution line. If this starts to leak, that's it. You can't isolate a boiler. So better don't throttle this valve. And next comes the pressure gauge. So usually this must be calibrated and then working in a perfect condition. And if there's no way at sea you can change the pressure gauge, there must be the error which has to be marked over here. Usually you can find this in older ships. The error is marked until the next recalibration is done on this pressure gauge. So the red needle is indicating the maximum operating pressure, and this is the current working pressure is the black needle. And let's now go to the main feed check valves. You can usually find the main feed check valves on top of the boiler, near the safety valve area. You can usually find it. The feed line right from the hot well area, from the boiler feed pump, it climbs up through the boiler and then supplies the water to the steam drum, where the water gets collected, and from there the circulation starts. So you can always find the main feed check valve on top of the boiler. There will be 2 valves, so if you have to throttle, if you don't have a controller like in olden ships, you got to throttle only the second valve, which is away from the boiler. The one which is directly connected to the boiler must never be throttled. That's the idea of having 2 valves. Now this is the water level controller, or the feed regulating mechanism. Like, let's say the water level in the boiler is optimum. Now this control valve will start to slowly close down, allowing less water to the boiler, just coping up with the steam load. So in the future videos we will be discussing about the complete mechanism of how the feed water is regulated. And the next shows the gauge glass, which is very, very important. This is the exact view where you go on a watch and you got to see the water level. Hope you guys can identify the water level. It's over here. So this is the water level. You got to have a cross painted strip or a light which is different in color, so that you can see the water level easily. That's the idea of it. And this is the other view. Here is the bulb which is enclosed, and this is the gauge glass. You have a drain cock here, the water cock here, and the steam cock here. So this is the arrangement. And you can note a small strip written something. So when you look at in the front view, these strips will show the lowest water level, low water level, normal and high water level. These are the strips, and here is one. So it will be clearly written on it. Olden boilers you don't find it, but new boilers definitely there will be a stamp which is the normal water level. And in some big boilers you can find how much let's say here the normal water level will be 0, and anything above the normal water level will be plus 10 mm, 20 mm, 30 mm, up to 150 mm. Roughly I'm saying the value. And below 0 is minus 10, minus 20 mm, 30 mm. Just it's a reference value. So when you calibrate the water level controller and the differential pressure transmitter, when the boiler is at normal working level, that is 0 over here, the DP transmitter should also be showing the same corresponding value. Now let's move on to the next mounting, which is the scum blowdown valve. As I said earlier, it should be slightly below the normal water level. So the idea is to have just to scum off the floating debris out of the boiler. So since it's set as floating debris, it is always found on just near the water level. So that's the reason we have near the water level, and we have two valves as usual. So the idea is, as I said earlier, the second valve you can throttle it, and the first valve should always be kept open when you blow down. During normal operation, both the valves should be kept full shut. And the next mounting is the bottom blowdown valve. So this is the boiler casing, and you have two valves for the bottom blowdown. After this valve, it goes to the bottom platform, and right in the bottom platform it connects to the ship's hull and then goes overboard. So most of the ships have 3 to 4 valves, but the textbooks say 2 valves or 3 valves max. So this is what we actually find. So whenever you got to blow down, you got to keep this valve completely open and throttle with this. And here is the same, like you got to open this valve completely. If you have one valve on the boiler, you got to throttle with this. That's the idea. And here is the sampling cock. You got to be very, very careful with this valve. This valve tends to leak very often. This sampling cock carries the same steam pressure of the boiler. So 7 bar steam, and if you say you do the boiler water test every day, so the valve tends to leak. So be very careful when operating this valve. And this is the sampling arrangement right from the boiler. The boiler water, in fact the boiler water comes, and let's say the boiler water inside the boiler is at 7 bar. So the temperature of the water is of the order 130 degrees or something. I'm just saying a rough value. What happens when a 7 bar water comes to atmospheric pressure? Let's say 1 bar, 1.013 bar. So it immediately flashes off into steam at the atmospheric pressure. So the idea of collecting a sample is to have a cooler here. Here is the sample water cooler. What it does is the boiler water is cooled down to roughly 90 or 80 degrees Celsius, and you got to refer your water treatment manual. What is the ideal temperature of collecting water sample? You usually have a thermometer and a cooling water line from the freshwater circuit of a shipboard system. You will be having it. And the next mounting would be it's an accessory, not a mounting, and this is the easing gear which I was talking about, which is connected to the safety valve. So you will be having 2 easing gears operating each safety valve. So since most of them has never operated it, so in emergency people think that we just pull it. No, you can't just pull it down. You have to screw it out, like you got to turn it clockwise or anti-clockwise for open and close respectively. That's how you can open. Easing gear, you can even keep the safety valve open for 1 turn or 2 turns, something like that. So it also depends on various manufacturer type. If you have a thread, refer to the manufacturer's manual and decide upon the operating system on your ship. And this is what the current scenario of boiler is. This is a typical gauge glass again, and you have, as I said, the strip is there, the very low water level and the normal water level marked here. You have the cock, that is steam cock over here, and the water cock here, and the drain cock here. So these cocks are somewhere on top of the boiler, which is not normally easily accessible. So in order to blow down a boiler, which is very tall, when you blow down from here, you can't see what is coming down near the funnel on the boiler combing. So the recent generation boilers have a rope tied to a pulley arrangement so that one can stand near the funnel and watch what's coming out of through the drain lines. So when you operate it with a lever, you can just see what is coming out of the funnel. Alright, so that's the idea of having these ropes. And yeah, this is how the wiring wire and pulley mechanism for the gauge glass looks like. Here it's clearly marked open open and shut shut for bottom and top cocks. So this is a typical boiler water plug, and if at sea if some tube leaks, you got to plug the boiler tube with this. So make sure you identify such plugs before you set out to sea.